Okay, so I'm just gonna do a summary video over what we talked about in class today. So first of all, your 5 shapes. We made a chart, and what we did is we counted vertices, which are corner points. We counted the edges, which are where you fold them, and then the faces are what they're made up of. So like these are made up of squares, these are equilateral triangles, these are equilateral triangles, these are equilateral triangles. This is made up of regular pentagon, which means every angle and every shape is the same. And so what we did is we counted the faces, the vertices, and the edges for each, okay? And so if you look at my dot cam here, let me get that up. So this is a cube, which was one of our things. So the faces are squares, and I have 1, 2, 3, 4, 5, 6. So I have 6 faces. Vertices are the corner points, 1, 2, 3, 4 up here, 5, 6, 7, 8 down here. So that's 8. And then edges are where we folded, so where it bends, so line segments, 1, 2, 3, 4, and then going up and down, 5, 6, 7, 8, but then we also have the 4 on the bottom, 9, 10, 11, 12, okay? And what we did is we made a chart counting them. So we counted all the faces, all the vertices, and all the edges for these. So like an octahedron, I don't know if I can draw it very well, but it kind of looks like a top. All right, but there's 8 sides, like there's kind of some sides hidden back here, some sides hidden back here. All right, and so if you think of faces, there's 1, 2, 3, 4 triangles on top, 4, 5, 6, 7, 8 on bottom. So this is what the octahedron. Vertices, there's 1 on top, 1 on bottom, that's 2, but then there's 3, 4, 5, 6. So there's 4 there, 5, 6. And then edges, there's 1, 2, 3, 4, and then the middle, 5, 6, 7, 8, and then the bottom, 9, 10, 11, 12. All right, and so you can do that for all your shapes. So if you miss class, you can go ahead and try to do your best. We used highlighters in class to highlight them. And then we looked for a formula. And so students discovered if you take faces plus vertices and you subtract 2, you always get the edges. And so see how that worked here too, 14 minus 2 is 12. Some people do faces plus vertices equals edges plus 2. That's just a little algebra manipulation. So if you take this 14, it should add up to 12 plus 2. So if you miss class, you can go ahead and do the math on these, figure out the faces, vertices, and edges, and then make sure this formula works, okay? And you should only get even numbers on that. So that's kind of how we started class. All right, I'm going to pause. If you look in your packet, find the stuff dealing with polygons and interior angles. So I'll be right back. So next we looked on your packet. This is page 21. And it says, use triangular pattern blocks to create a hexagon. Sketch your figure below. What type of triangle is used to create the hexagon? What is the sum of the interior measures of each triangle? Okay, so we have some stuff going on here. We can cover it up. And so every triangle adds up to 180. And these are regular, meaning every angle inside is the same. These are equilateral, which is the same as a regular triangle. So these are all 60, 60, 60. But notice they make 360 in the middle because it makes like a circle there. But then like these outside angles would be 60 and 60. That's 120, 120, 120, 120, 120, 120. Okay. These are called central angles if they're here. These angles in this shape, this polygon, are called interior angles. If I want an exterior angle, then what I would do is, so like say I have a pentagon, these are called the interior angles in here, right? And they're not probably all the same, you know, some might be different. An exterior angle is like when we extend that out and we want this angle. So this is called like an exterior angle. These are the sum of the interior. And then if I want to put like a spoke in the middle and kind of draw triangles, we call these like the central, let's see, 1, 2, 3, 4, 5. This is called like the central angles, okay? All right, so if we look at it, Ryota thinks he can find the sum of the interior angles of the hexagon without using a protractor. So what he's thinking is he knows there's 180 degrees in a triangle. And so he's like, ooh, I have 6 triangles, right? there's 6, 1, 2, 3, 4, 5, 6. And so 180 times 6 is what, 1080, so 0, yeah, 8, 4. So, but the problem is he knows that he only wants these shaded angles in the corner because those are what the angles of the polygon are. So he has extra angles he needs to subtract, which is 360, because he created an extra circle in the middle, and he gets that there's 720 degrees, okay? All right, so if you flip the page, what if it's not a regular shape, okay? So at the top of page 22, you know, you have this polygon that is it a pentagon? Is it 5 sides? But notice that it's not equilateral, like nothing's nice. Can he still put a point in the middle and draw his triangles? And the answer is yes. Now, they're all going to add up to 180. It's just they're not going to be evenly split. So if this is 180 times 1, 2, 3, 4, 5 triangles, and let's see, so what do we have? 40 and 5 is what, 900 degrees? That would be okay, except he added all these extra angles in the middle that aren't part of the shape. See how only the exterior angles, so I created new angles. So I'm going to have to subtract 360, so what is that, 540, to get that. Because, and these are the exterior angles, because those are the only angles in my shape, right? Like this angle is part of my shape, this angle is part of the shape, this angle, this angle, this angle. None of these angles are part of my shape, okay? And a polygon is made of line segments, and it is closed, meaning you can't get into it. This is open. We need it to be closed so that we can't get into it. That's a polygon. Concave means it caves in, but it's still made up of line segments. So it just caves into itself. So concave. Convex means that it doesn't cave into itself. So it all kind of goes out a little bit like that, okay? There's no curvies on these, right? So if you have a curve, then it's not a polygon. Polygons are just straight line segments that are closed, okay? All right, so let's see. Let's do letter B on page 22 in your packet. All right, so we did this one. Now we're looking at B, okay? And it says, what about a quadrilateral? And a lot of people in class, they knew a square or a rectangle would be 90, 90, 90, and they're like, okay, 90 times 4 is 360. But what if it's not 90s, right? So like, what if I have, you know, a parallelogram or just some weird four-sided shape, right? So let's do his method. So we're going to cut it into triangles. So kind of put a spoke in the middle and then draw your triangles. All right, so, all right. And so 180 times 4, 180 times 4. Even here, do you see how you have 180 times 4? If you draw your spoke. So 180 times 4 is 720. All right, but again, on all of these, you see how you have that 360 air in the middle, that extra circle. So you subtract 360, and you do get 360 degrees. So all shapes have 360 if they're a quadrilateral. Okay, and then C says, use Ryota's method to find the sum of the measures of a dodecagon. So 10 sides. And so we talked about if it's 10 sides, there are 10 triangles, because each triangle comes off a side. And again, I could try to draw it. I did it in class, but I drew a 10-sided shape, put my dot in the middle, right, and drew my little spokes from there. Okay, and notice it always makes a circle in the middle. So I have 10 triangles. Each triangle is 180. So I have 10 triangles. They're all 180, so just tack on a 0. And then again, the air in the middle is always a circle, always. So subtract 360, and you get 1,440 would be for that shape. And then on the next page, we summarized it. So number of sides equals the number of triangles times 180, and then you subtract the error in the middle, that 360, those extra angles you added. Another way, if n is the number of sides, you would take 180 times n minus 360, and again, that's that error. All right, flip the page and look at Jolie's method, and I'm going to pause and we'll pick up with her. Okay, so Jolie's method is different in the fact that she doesn't do any overlapping. So what she does is she picks a vertex and she just draws triangles from there. So like one triangle there. And you see how she doesn't crisscross? So she didn't create any angles in the middle. Like the angles of this triangle are all part of the outside, these interior angles of that polygon, right? Like there's nothing new extra created in the middle. And so she's like, oh, well, it's 180, 180, 180. 180 times 3 is 540 degrees. And she's done. Like, she's like, well, I don't have an error, right? Because I know that I have exactly 183 times without overlapping. And again, we can figure out these missing angles then once we get our budget. So like once we know that this is all 180 each, then like these might not all be the same. So like this angle might be say 140, and this one might be say 80, and this one might be 120, and this might be 100. Then we can say, okay, the budget for all of them is 540. And then we can add up what we have. So there's 200 and what? 140, and that is 240. So there's 440 is kind of spent. So this is like your budget for the shape. This is what's spent. And if you subtract, whatever's left must be, you know, that guy right there. Okay. All right. Now, if it's a regular, like say I draw a perfect regular, and again, the word regular means that all of the sides and angles are equal. So like every side is the same, every angle is the same, everything's congruent. Then if I did my 180 times 3, and again, just pick a vertex and go from there, then you get 540. Notice this time I don't know what individual angles are, but I do know they're all the same. So I have 5 groups sharing this. So if you take 5 into 540, what is that? 040 would be 108. I know that these are all 108 degrees. Okay, but that only happens because it's a regular shape. Everything's the same. All right, so then we did the ones on the bottom. So arm 6, we cut it into 3 triangles. 180 times 3 is 540. And then here we cut it into 1, 2, 3, 4. Again, 180 times 4 is 720. And then here we cut it into 5, and we got 900. And notice that we took the number of sides minus 2 all the time. And that should make sense because if you have a shape, side 1 just makes a line segment. Side 2 kind of creates an angle. Do you see how you need the third side before you start making triangles? So that's where that n minus 2 comes in, is that the first 2 sides wouldn't make a triangle. You need that third side to make a triangle. All right, and then we generalize this. So we said, oh, if we take the number of sides minus 2 times 180, we get the answer. Okay, and so if n is the number of sides, we get n minus 2 times 180. So hers, there's no fix later. So if we look at his, we take 180 times n. This is where you do the middle, like the spokes coming out. But then you make this extra circle in the middle of angles that you don't want. So you subtract 360. Hers, you pick a vertex to start from and make triangles from there. And so on that one, you just take n minus 2 times 180. And notice if you do the distributive property, you get the same answer, which you have to because they're really the same formula. All right, so then we did the odd ones. So we did number 1, like, again, it's a 5-sided shape. We took 180 times 3. I like her method. If you do the 361, totally fine. Subtract your budget, you get 120. A triangle has 180. I know it's a right triangle, so there's 90 and 57. And again, subtract that, which is what, 147, and subtract to see what's left. The next one, the sum of the measures of an interior angles of a polygon is 1080. Again, you could use the formula. You could use the distributive property, add and divide. Or you could guess and test. So guess 8. And then 180 times 6, because again, n minus 2. And notice I got the right answer. So I know it's an octagon. This is 6 triangles. Okay, so you could guess and test. See how that works. Next page, we did the odds again. Cut it into triangles. Again, 180 times 3, 540, 90, 90, 90, and 122 are gone. And see what's left. And again, if you like his method better, you put a dot in the middle. All right, and you take 180 times 5, but then you subtract 360 and you get back to the 540. So you're going to get the total the same way either way, and then do this angles. 180 minus the 2 angles you're given, that guy's left. And what is the sum of interior angles? It is a, what? Let's see, I think it was a 9-sided shape. So 180 times 7 is that. Again, you could take 180 times 9, get that answer and then subtract the air in the middle if you're going to do the spoke idea.